Have you ever stopped to marvel at the wonders of the natural world? A blooming flower, a soaring bird, even a simple glass of water all hold secrets waiting to be unlocked. These secrets lie at the intersection of two fundamental sciences, chemistry and physics. Chemistry, the study of matter and its transformations, and physics, the study of energy and its influence on matter, might seem like separate disciplines. But in reality, they are intimately intertwined, working together to paint a complete picture of the universe and everything in it. Think of a burning candle. Chemistry explains the combustion process, the transformation of wax and oxygen into carbon dioxide and water. Physics steps in to explain the heat and light emitted during this chemical reaction, the transfer of energy from one form to another. Understanding both chemistry and physics is crucial to grasping the complexities of our world, from the smallest atom to the largest star. It allows us to appreciate the elegance and interconnectedness of the natural world and empowers us to unravel its mysteries. Let's start our journey by delving into the building blocks of matter atoms. Atoms, the smallest unit of an element that retains its chemical properties, are the fundamental units that make up everything around us. Physics helps us understand the structure of an atom, composed of even tinier particles called protons, neutrons, and electrons. The positively charged protons and neutral neutrons reside in the atom's nucleus, while the negatively charged electrons orbit around it. Chemistry enters the picture by explaining how these atoms interact with each other. The arrangement of electrons in an atom dictates its chemical behavior, its tendency to form bonds and create molecules with other atoms. A single carbon atom, for instance, can bond with 4 hydrogen atoms to form methane, a key component of natural gas. This simple molecule, with its specific arrangement of atoms, highlights the beautiful partnership between physics and chemistry in shaping our world. Now let's talk about energy, the driving force behind all change in the universe. Energy exists in many forms, and physics provides the framework for understanding its various manifestations. Kinetic energy is the energy of motion, whether it's a speeding car or a vibrating molecule. Potential energy, on the other hand, is stored energy, ready to be unleashed. A stretched rubber band or a rock perched on a cliff possesses potential energy due to its position or state. Chemistry comes into play by explaining how energy changes influence chemical reactions. Some reactions release energy like the burning of fuel, while others require energy input to occur, like photosynthesis in plants. The study of energy changes in chemical reactions is called thermochemistry, a fascinating field that bridges the gap between these two fundamental sciences. Section 4, the rules of the game, thermodynamics and kinetics. Just like a game has rules, the universe has its own set of governing principles, and these are encapsulated in the laws of thermodynamics. These laws dictate how energy behaves in systems, from the smallest cell to the vast expanse of space. The first law of thermodynamics, also known as the law of conservation of energy, states that energy cannot be created or destroyed, only transformed from one form to another. The second law introduces the concept of entropy, a measure of disorder or randomness in a system. Kinetics, another critical aspect of chemistry, delves into the rates of chemical reactions. It explores factors like temperature, concentration, and catalysts that influence how quickly reactants are converted into products. Understanding these principles helps us predict how systems will behave, whether it's predicting the yield of a chemical reaction or understanding the energy flow in ecosystems. Section 5, Quantum Chemistry, a peek into the subatomic world. Our final stop takes us to the fascinating realm of quantum mechanics, a branch of physics that revolutionized our understanding of the subatomic world. Quantum mechanics describes the bizarre and counterintuitive behavior of particles at the atomic and subatomic levels. One of the key principles of quantum mechanics is wave-particle duality, which states that particles like electrons can exhibit both wave-like and particle-like properties. This concept is crucial for understanding chemical bonding, the force that holds atoms together to form molecules. Quantum chemistry uses the principles of quantum mechanics to explain and predict the properties of molecules and their reactions. It provides a deeper understanding of chemical bonding, molecular structure, and spectroscopy. Recent advances in quantum chemistry are paving the way for exciting new technologies, from designing novel materials with tailored properties to developing more efficient catalysts for chemical reactions. This field exemplifies the power of combining physics and chemistry to push the boundaries of scientific knowledge.